Greetings and welcome to my new calculus channel. So, further to my previous video on the greatest common measure, or rather what's known as the greatest common divisor, I'd like to just clarify a few things. So, first of all, note that we can replace all the occurrences of divides by the word measures, okay? And there's a good reason for that because in arithmetic, that's what division does exactly. It measures, okay? What does it measure? Well, the divisor measures the dividend, right? So as we see here, if 20 is measured by 12 and 8, that means we can use 12 to measure this far, as you see over here, and then measure another 8, and we've completed the measure of 20. That's what it means, okay? But now, the task at hand here is not just to measure 20, but to find the greatest common measure of 20 and 12. So I asked Claude to rephrase its first response here, which it used divides. So, for example, it says, sure, let's walk through how the reasoning process you outlined arrives at the greatest common divisor using the Euclidean algorithm of 20 and 12. So you start by recognizing that for finding the greatest common divisor of 20 and 12, you should not try any number greater than 12. Why? Because it won't divide 12. This makes sense, as the GCD must divide both numbers. So then you try 12 itself. Since it trivially divides itself, 12 divides 12, anything divides itself exactly or measures itself exactly. And if it also measures 20, then 12 would be the GCD. So again, you say dividing 20 by 12, you find that 20 is equal to 1 times 12 plus 8. So 12 divides 20 once with the remainder of 8. Since 12 does not measure 20 exactly, you reason that if 8 measures 12, then it must also measure 20 because 20 is measured. I don't know why I chose to use measured here instead of divides, because it's measured both 12 and 8. Do you know why? Very simple, because that's what you're doing when you performing division, right? You're measuring. So basically, if we go to the paint brush, we'll see that 12 and 8 measure 20, okay? So coming back to what it says, it says, so you divide 12 by 8, and 12 is equal to 1 times 8 plus 4. So once again, 8 measures 12 once. You could have also said, so you measure 12 by 8. So 8 measures 12 once with the remainder of 4. Okay, so you need 8 plus 4 to measure 12. And again, applying the logic that if 4 measures 8, then it will also measure 12, since 12 is measured both by 8 and 4. And consequently, 4 will also measure 20, since 20 is measured by 12 and 8. So finally, measuring 8 by 4, you have 8 is equal to 2 times 4, and you find that 4 measures 8 exactly with no remainder. Therefore, 4 is the greatest number that divides 20, 12, and 8 with no remainder left over. It is the greatest common divisor. Now, notice what Claude concludes. This recursive reasoning of dividing, or recursive reasoning of measuring, taking the remainder, measuring the previous divisor by the new remainder, and recognizing that any common measure must divide all the remainders as well as the original numbers, is precisely what the Euclidean algorithm formalizes. Your thought process elegantly walks through these steps to arrive at the greatest common measure of 20 and 12 being 4. Then just the last response, it says using measures reinforces. Okay. Using measures reinforces the fundamental principle of the algorithm based on repeated measurement until no remainder. Thank you for the helpful feedback to improve the alignment with the measurement overview. So, the reason I'm stating this is that in order to be more effective in teaching the Euclidean algorithm, this is the Discord server, by the way, that you see in front of you. you should be made of the word measures rather than divides. And in Claude AI's final response, where I asked it to do this, it reaches a conclusion as follows. It says, using measures reinforces the fundamental principle of the algorithm based on repeated measurement. Okay, and that's what I just read to you. So there is no difference between the word metrici and diaresi with respect to, or diaresi, sorry, not diaresi, diaresi, with respect to the arithmetic operation of division. So students quickly understand measurement, whereas division is shrouded with mystery even from their first conceptions. In fact, division should be taught as a measurement. All right. Now, if you're not already a subscriber, become one. Click like, follow me on academia. I'll place links to all these things. Here's the original article that you can read. Brilliant article. And I'll insert page numbers. I forgot to do that, but I'll do that afterwards. And if you want to join our Discord server, you'll have access to the lobby where I sometimes discuss things like this. But in order to have access to the other channels, you will have to become a member and pass a 10-question test on the new calculus and the Holy Grail. So my name is John Gabriel, and this is the New Calculus channel. Till next time, goodbye.